Hey, do you own a company? You don't know how your production works, you lost your overview, you're totally stressed?
Yes.
I have the solution for you.
What solution?
Let me show you. Here it is. The Simplified S.P.M.C, the Systematic Planning Manufacturing Cells.
And what does it mean?
Oh, it's like a manufacturing cell is a set of machines put together for products which are produced in the same way. But let me introduce you in a more detailed way.
Okay. So how is it working?
Let me show you. Here, I have here some documents for you that you can see. The method of simplified S.P.M.C follows 6 steps. Here you can see that the first step is to orient the project. This means that you have to get an overview over your projects, your planning issues, and that you make a plan what you want to achieve with the project. After this step, you have step 2 and 3, which is like to classify the parts and to analyze the process of your production of your parts. So after these 2 steps, you should know which are you producing and how do you produce it. In step 4, you have to couple into cell plans. So when you know what you're producing and how you produce it, you can order this into a new shape and make your cell plans. Let's say after this step we have 3 different cell plans. So in step 5, you have to decide which one is the best of them, which means like it's written here, select the best one. In step 6, when you already know which cell plan you will use and how you will shape your cell, you have to implement it and install it. After this, you are finished, have your production cell plan. This is the orientation issues worksheet. In this example, we are producing cylinder housings. First of all, you have to identify your objectives and what you want to achieve. Then you have to describe your external conditions, where your cell will be located. Then you have to describe your situation and what problems you are facing. After all, you have to define the scope of the project, how big, how detailed, and when it is needed. The second part of the orientations and issue worksheet is planning issues. First, you have to define your issues and then give them an importance. Here, for example, the first issue is that the team needs time for planning, which is classified with an E, for especially important. After you have your finished manufacturing cell, you can fill which actions was done to resolve the issue and to propose the solution. We will follow this step when we are finished. The third part is the project schedule. The project schedule is a timetable where it is visible which steps the project has, the responsible person for each step and the given time for it. Here, for example, step 2 is to classify the parts, which has to be done in the first 5 days of the project time. The responsible person has the initials JD. During the project, the timetable is used to see the status of the project. The day, which is marked with a V in the top, is the status update day. Here we updated it to see if we are in time or not. We can see that, for example, the classification of the parts is not in time, because the small marked place with the black marking is shorter than the given time, and we are over the time. But for example, the analyzing of the process is ahead of the schedule. Now we have to classify the parts which are produced. This is done in the product part classification worksheet. In the first column is written the name of the product or part, which you can see here. Then the basis material, for example here steel, and the physical characteristics have to be documented. Here, for example, the quality level for the first part has an A, which is for abnormally great. The size is an O for ordinary. The weight density is especially significant. The shape, for example, has an FL, which means flanked. We can see this here in the reference notations. The next column is for other considerations, which are described at the bottom of the document. This can we see here. For example, Q for quantity, volume, demand, or R for routing, process domination. Further, there's also place for further explanations and more informations or notes. Frequently, the classification is primarily based on the process operations.
Third sheet is group of parts process chart. In this step we have to analyze the process and to describe the operations that change parts. First of all, we have to write down the part numbers and quantity per year to be produced. Also, it is useful to write the name of each class at the bottom of the form, for example, old style, deluxe or conventional. Then we have to enter the name of each operation, for example, drill, wash, polish, and the number of machines that are doing those operations. The next step is to show the sequence of operations for each class of parts. Some of the parts have to go through 8 operations, other groups of parts can have 14 operations. Thus, it's important to indicate the movement of parts between 2 operations with a vertical line. Next step is to enter the time required for the operations. It can be minutes per piece or hours per 100 pieces. Then we have to calculate the number of machines required for all parts for each operation. And if there is a need of any reference notes or explanations, we can write them in the right side of the bottom.
For a better process visualization, it is useful to prepare equipment and flow diagram. In order to do this, firstly, on a blank sheet of paper, we need to find the operations through which the parts in all classes go. Then we start diagramming by lining up the equipment vertically. For each piece of equipment, we need to draw a square for each movement, a straight line connecting the 2 operations. All production classes have different routes. One of them goes through all the machines, while the other one skips some operations or goes through them several times. This diagram is very important because it helps you and others see how the parts and process relate. Also, it makes your production flow more visible and understandable.
Next step is couple into cell plans. We have to couple together the parts and the process. Firstly, we have to make a graphic layout. We can start with a blank sheets or existing drawing of the space available that shows the building columns and other fixed building features. Then we have to select a scale for fitting entire cell in one sheet. Next step is to identify each sheet with the date, project name, and the number. Then, following the equipment and flow diagram made in previous step, we have to place and draw representations of machines and equipment in particular shapes. Next step is to indicate the flows, at least for the dominant class of parts. Then it is important to indicate and write down how the parts will be moved or handled from one operation to the next. Also, we have to make references about the operations, and in the end it is useful to have several alternative cell plans because each plan has different features, benefits, costs, or risks.
After the step 4, we can come back to the planning issues which were discussed in step 1. Now we can identify the actions needed in order to resolve the problems, to decide who is responsible for taking these actions, and what is the proposed resolution for each issue.
Step 5 is to select the best alternative of the cell plan. We can evaluate them by comparing the costs or intangibles. Thus, first step is to mark whether this evaluation is for costs or intangibles. Second step is to identify each alternative by a letter and give a brief few words description for each of them. Then, if we have chosen to compare alternatives by cost, we have to list the elements of investment cost and write down the amount in the respective column for each alternative. After that, we have to down total the investment cost and determine the expected life of the equipment, and by dividing the total investment by the years, we can define the annualized investment cost. Next step is to list the names of the operating costs and also determine the required amount of expenses for each item. Then we have to down total the second group of costs to get the total annual operating cost for each alternative. Next step is to add the annualized investment cost and the annualized operating cost to get the total annual cost for each alternative. Finally, we can identify the lowest cost alternative.
I could not stop, but you now know, singing, come out.
Step 6. Detail and implement. In this final step, we have to make sure that details are covered from the standpoint of the cell plan, its requirements, and installation. For this step, we need an implementation worksheet which consists of 6 sections: plan, provide, prepare, install, hook up, and clean up. In this step, we need to answer 3 questions: what are the tasks, who is responsible for doing them, and when it needs to be done. We need to mark the status of the implementation of each task. For detailing, we need to revise several documents. At first, a detailed drawing or plan of the proposed arrangement of equipment and work areas, which includes layout of the whole cell and of each workstation. Secondly, the method of handling between each pickup and set-down point, such as containers or shelving. Third, the specific amount and location of utilities and controls, including floor drains, special venting, and similar supporting services. Also, we need a list of all equipment for the cell, a set of operating procedures, and any other particular requirements such as special training.
I could not stop, but you now know, singing, come out.
Hey, here we are again. After we finished our 6 steps, is everything clear?
More or less.
Okay, let's do it again, that we don't forget anything. The first step to project is on student scale, is it?
Yes.
Okay, perfect. Check. Classes or groups of parts are involved.
Yes.
Okay, an equipment and flow diagram is prepared.
Yes.
Wonderful. And the alternative cells are prepared.
Yes.
Oh my goodness, the best cell plan is selected.
Yes.
And the sample is detailed for implementation.
Yes.
Great! So what do you think about this method?
I think that method is perfect because after we applied the simplified S.P.M.C at our company, I have a clear overview of our plant, the product flow is much more faster and the lead times are reduced.
The way